Okay, welcome to this installment of electrostatic studies. Here we'll be looking at charging by induction, which is kind of to wrap it all together. If you can have understood everything up to now, this is going to be a breeze. It kind of puts it all together, and we'll follow the path of the electrons as they move to charge an object with the opposite kind of charge. Okay, so in this first diagram, we start with two spheres. Now they're going to be metal. They do have to be conductive in order for this process to work. Now we're going to bring a charged object, in this case a balloon, close to one of the spheres. Now the spheres are touching, so that means there is a path of conduction between them. So electrons that are in these two pieces of metal are going to be attracted to the left. Now that means we end up with an excess buildup of charge of negative next to the balloon and positive on the other side. Now if we pull, while still keeping the balloon in the same position, if we pull the right sphere away, it's going to take with it the sphere that lacks electrons, which means it's going to leave extra electrons in this one. So when we're done with the process, we're going to end up with a negative charge on this one sphere. Now if we take the balloon away, our process will be complete. And since these are metal spheres, you'll see that the charge spreads out at the surface. It's not staying in the middle of the conductor. In a conductor, the charge always spreads out on the surface because it's trying to get away from all the other charges. But again, we used a positive balloon and we got a negative object. Okay, it doesn't matter what particular items we use as long as they're metal and they're isolated from something else. So if we take a couple of metal Coke cans and we put them on styrofoam or plastic cups to insulate them from the ground, we can do the same process. The difference here is we're using a negatively charged balloon. So we got an excess of electrons on the balloon here. And what that means is this time, instead of attracting the electrons to the left, we're going to push those electrons away from us, building up negative charge over here and leaving behind positive charge over here. Now again, if you separate the two, that's going to leave this one with positive charge on it. Now we may have to make sure that we keep the balloon there until they're separated, otherwise they'll just return to their natural state. Now if I do take the balloon away at this point, the cola can here is going to end up with a net positive charge, which is opposite to the negative, which is what always happens when you charge by induction. So there are a few points that go with charging by induction as illustrated here. It's not conduction where we touch. We're never going to touch the object directly with our initial charge. There's no transfer of electrons from the initial charged object. Okay, it's polarizing. It's going to cause the objects to polarize. That's why it has to be a conductor that we're going to try to charge by this method. So the charged object again polarizes the object being charged, puts a positive charge on one side and negative charge on the other. And then the object being charged is going to be touched to some source of electrons or a place where electrons can go. That could be the ground, or it could be another sphere or metal object, as we've shown in the first two. The electrons will transfer either between the ground and the object being charged, either into it or out of it, depending on which type of charge you're using. Now, since opposites attract and likes repel, when you bring the electrons in or out, the object being charged will always get the opposite of that which you start with. So again, if we start with something positive and we use induction to charge a neutral, we're going to bring this close by. That's going to polarize. It's going to bring the negatives over here, leaving the positives over here. We're going to touch that to the ground or another object big enough to be assumed to be the ground, like a person's finger or another metal can. That's going to allow, in this case, the electrons are going to want to be pulled. See how the electrons over here are on the left? Well, electrons that are down here are going to be pulled in. Now that means we're going to have an excess of negative charge build up on this object. When we then again take this away, we end up with an object over here, the metal object here, which has become negatively charged. It's the opposite of the positively charged object that we started with. Okay, so some quick check your understandings. The two neutral pop cans are touched. Positive charge is brought near the cans. The cans are separated while the balloon is nearby. After it's removed, the cans are brought back together. When touching again, can X is... Okay, now, when they come back and touch, after they touch, the two are just going to be back to neutral. Okay, so in this case, we did not create a net charge on these two. We just separated the charge. When you bring them back together, we're back to neutral. Two neutral conducting cans are touching together. Positive rod here is brought close by. So if we bring the positive rod close by, that's going to keep electrons over here and leave behind protons over here on this side. So again, it's induction, so electrons are never going to jump. There's not going to be a transfer to the glass rod in any way. They're going to move from can Y to can X, but they never move to the glass rod. So none of those are possible. It can't be protons that move. So the simple answer is none of these occur. Oops. Here we go. All right, nice simple true or false. Two are touching each other. A negative charge balloon is brought near the can as shown below. As the balloon approaches can... Okay, so this is an easy one. It's got to be false because there's never a transfer between the charging object and the can we're charging. It's only between, if there's only a polarization going on. Okay, positively charged balloon is brought near a neutral conducting sphere shown below. While it's near this, we have a grounding going on. That's the process of induction. So the movement of electrons will be, this is positive. Since it's positive, it's going to pull the negatives over here. That means it's also going to pull the negatives in from the finger or the hand. So it's into the sphere from the ground. Yes, it's not out. It's not from the balloon. It's never from the balloon. It's only from the ground. Again, not to the balloon and nothing with the balloon. And it isn't. So it's the first one. We're going to pull them into the sphere. Now we had positive. That's going to give us a negative net charge when we take the balloon away and the ground away. Okay, negatively charged balloon is used to charge through induction. The process is described below. Orientation of the needle. Okay, so neutral, the needle straight up and down. It's not charged. When you bring the negative close by, it's going to pull. Going to push the negatives down below, leave the positives behind, and we'll get the needle to move. In diagram 3, when you ground it, while you are grounding it, you're going to go back to neutral. Okay, during that time, the electrons will be balancing out. Now, once you pull the ground away, you're going to get a charge. In this case, it's because you have pushed electrons down through the finger. So that means you're going to have positive everywhere on the electroscope. Again, you take the balloon away and positive on the electroscope. Okay, and finally, negative charge balloon is brought near the neutral. Charge of the sphere will distribute itself in a very specific manner. Now it's a negative, so it's going to push away negatives. So that's not separation, so it couldn't be either of those two. It's got to be one of these two. Since it's negative, it's going to push the negative to the right. So this is what's going to happen. It's never that likes come together. They always repel, so it's not D. So the correct answer is C. And that's it for this episode, which is charging by induction. Sorry.